What's going on? So I've got a whole bunch of empty tracks here, emulating different types of session structures that I might use. Up here we've got a little mini music mix. I've got the tracks labeled how I would normally label them in like a traditional band setup. Down here I've got a film mix, a mini film mix, how I would normally label the different elements. And what we're going to do is this will probably be the first part in a series of videos relating to making a script to automatically color tracks, either by rule or by something else. Now, before I, get into this whole thing, inside of the SWS extension, I think it's there, you can set up rules to do this automatically. So if this was something that you were interested in doing, but you wanted to do it a lot quicker and a lot easier, maybe look into that. I suppose the reason why I went down the scripting route for this is I wanted to be able to do, more with it. Not just the automatic naming of coloring of tracks by name. Something that came up recently was like I was doing this big edit and it involved like dragging items onto tracks many times, like distributing them. And so one of the permutations of the script that I do is just random colors for tracks, making sure that no adjacent tracks have the same color. Purely for the purpose of creating contrast, so that when you're dragging and dropping, it's easy to see where you're at. And that's actually going to be the thing that we do in this particular video. Starting off relatively simple, making the random track colors, and then we're going to move on to coloring by rule. I think this is a really important one because just from a workflow point of view, I highly recommend creating a color scheme, a color convention for yourselves, and always stick to it. You don't have to do the same colors that I do, but I've used the same color scheme for over a decade now, and the advantage of that is I can open up a music mix from 2012, and I know that the colors are going to be what I expect them to be, meaning drums are always brown, guitars are red, pianos and synths are green, vocals are pink, effects channels are dark green. And the advantage of that is, the brain sees color quicker than you see the words, so it's a lot quicker to find your way around the session. Unless you're, of course, colorblind, in which case I apologize. This might not be the script for you. So yeah, those are my colors for music. For film and television and sound design, dialogue is yellow, print tracks or render tracks are red, effects tracks are dark green, sound effects tracks are orange, Atmos is green, music is pink, and I forgot one, Foley is blue. So those are my colors. Like I said, you don't have to follow my color scheme, but I would recommend having a think about one and starting to do colors the same way from now on, because you'll thank yourself later when you're opening up old sessions. Cool. So what we're going to do in this first video, we're going to start our script by just doing a random assignment of colors, just to create contrast between the tracks, which can be useful. So open up our actions, go new action, new rear script, put it in our favorite folder. Let's just call it color tracks. Alrighty. So we start with our function, declaration, and then at the end we call the function. All right, so what are we going to do? I guess this is the first of our design decisions. Do we want to have the script such that, you know, when you highlight the tracks, you run the script, it only runs the script on the highlighted tracks? Or do you want to be the case that it doesn't matter what you're highlighting, it just does it for the whole session indiscriminately? That's a decision that maybe I'll leave up to you. It's only a minor adjustment if you go down the path of selecting tracks. But what I'm going to do is I'm just going to do a script that runs for the whole lot. Yeah. So how's it going to work? So we're going to get the number of tracks in the project. Okay, get the number of tracks in the project. And now we looked at this in a previous video. In a previous video, we did look at the for loop. And what a for loop is, you can have a repeated set of instructions, and the code goes through them in a predetermined number of times. I said that really awkwardly, didn't I? You have a preset set of instructions, and the script will go through those instructions again and again until it reaches the quantity of loop iterations that you tell it to do, right? So what we're going to do in this case is, in a for loop, we are going to do the following. For as many times as there are tracks. Hopefully that makes sense. We are going to get a reference to the track. And eventually we're going to color the track, that random color. Pick a random color and color the track that random color. Now, just a quick note on that. You know, you could set up this script so that the color that it chooses is like purely random, right? Because how it works in Reaper and in a lot of programs, color is defined by the 3 primary colors, red, green, blue. And each of those primary colors has 256 values. So 256 values, and they're all interchangeable. And I think from memory, the total number of colors that gives you is 4 million and something. I think that's right. It's definitely in the millions, whatever. It's a big number. So lots and lots of colors. So it could go down that route where it generates a purely random color out of those 4 million, or is it 14 million? I can't remember. But I'm not going to do that. What I'm going to do instead is I'm going to define a short list of colors to pick from, and then pick one of those random colors, sorry. So I'm going to define the colors up here in a table. So this is how you declare a table. Table equals, and then you've got the curly brackets, and then your contents of the table are inside those curly brackets. Now, just a quick note, you'll notice that I declared this table outside of the main function. Now, you could definitely put that in here. That'd work. I suppose I typically put predefined data at the top of the file outside of the main function, and that's just more of a choice thing more than anything else. I suppose in my mind, anything that's outside of the main function is just data that we're going to use, as opposed to logical statements and executed lines of code. Those sorts of things I would put in the main function, but predefined data I usually put outside of the main function, and that's just I suppose a personal choice. All right, so what colors do we want? I suppose what we might do is, well, I mean, you could pick the colors that you want, but what I'm going to do is I'll probably go through my standard colors here, and we'll just use that as the list of colors to pick from with the random colors. Cool. So we've got red, we've got green, we've got a dark green, which I usually use for effects returns. We've got blue, orange for sound effects, pink for vocals in Music Land, brown for drums in Music Land. That might be it. Sound effects, Atmos, dark green, blue, orange, green. Yes. Okay, they'll do. 7. That's fine for now. So these will be our colors that we pick from. All right. So let's replace this comment. So how this is going to work precisely is we're going to find out how many colors are in our colors table, right? And I'm just going to leave a note for myself. This is hash colors table. In Lua, that's how you find out the number of elements in a table. Hash colors table gives you the number of elements. So pick a random integer between 1 and the number of elements in a colors table. Use that index to pick a color. So this is one of the ways that tables can work. They're indexed elements, and you can access one of the elements by asking for the that index inside of colors table. I said that really awkwardly, didn't I? Use that index. So what that would mean would be something like random color equals colors table square brackets, pick a random index. So what are we going to call this when we actually do it? Random index, sure. Right? So there's 7 colors here. We pick a random number. Let's say it comes out as 5. And then when we're actually getting the actual color, we're looking inside colors table for the 5th element, which will be orange. And then the next time we run it, it might be the 2nd element. So colors table number 2 element is green. So hopefully that makes sense. So that is getting the actual color from the colors table, and then color the track that color. Cool. So there's one more thing that we need to add into our plan, and it's to prevent adjacent tracks having the same color. So what we're going to do is, there's a few ways to do this. What we're going to do is keep track of the previous color index that was picked, right? Meaning this. Pick a random integer, so this random index. So keep track of what the previous one was, right? And if it so happens that, so if random index is the same as the index of the previous color used, what would we do? I mean, we could keep it quite simple and like, let's say blue is this track, and then the next one, it wanted to do blue again. We could just do the 1 up in the elements. That'd be good. It would still create a nice contrast between the things. That's probably a fairly simple way to do it. move one index up in the table, right? So if we try and do element number 4 twice, the second one will actually change to 3. So then what happens is if we try and do this one twice, number 1, so let's say the first track is 1, the next track tries to do 1, so we'll have it so that if we're looking at 1 and we want to change it, we'll loop back to the top color. Move one index up in the color. So what that's going to be is if the index is 2 or more, move one index up in the table. However, if the index is 1, change the index to this index, the biggest number in the table, the last number in the table. That's what that'll give us. Okay, and that'll assure that we don't have any adjacent colors. And then once we finally picked the color, color the track that number. And what we want to do is, after we have finalized all of this stuff, this is where we keep track of this color to compare it to the color chosen in the next iteration of the loop. So that's where we actually keep track. Once we've done all the selecting process, this is where we store that index for use in the next loop. Cool. All right. So we've got our plan. I think it's pretty solid. Let's start moving through it. So get the number of tracks in the project. So we go to our API, and I think it's count tracks. Count tracks. There we go. So it returns an integer. That makes sense. Get the number of tracks in the project. Num of tracks equals Reaper count tracks. It wants to know information about the project. So like we've done in previous tutorials, what I like to do is assign a variable called active project and give it the number 0. So just to, I did talk about this in a previous video, but just to clarify, functionally speaking, this is exactly the same as just writing 0. Has the exact same effect. The reason why I do it like this is because it makes it a little bit more readable. It makes it very obvious what we're looking at. Maybe later on down the track, it's been a while since you've looked at Reaper scripts, you forget what the 0 means. But when it says active project, it's like, oh, okay, it's passing in the active project. That's very clear to me. Thank you. All right, so now we do our loopy loop. So in a for loop, we're going to do the following. For as many times as there are tracks, do the following. Okay, so the syntax for that is for I equals 1 until the number of tracks incrementing each time by 1, do the following. Right? So that is the translation of the comment that we just had. Now, just a quick note about this. I'll go through these arguments again. So we're starting at the number 1, and we're going to run this loop until we get to whatever this number is. It's hard to count. It may be 20 or 25 or something. So let's say 25. I'm not going to count. It's going to go from 1 to 25. And then this last one is what I increments by each time. and we want it to count up in 1. So the first loop I equals 1, second loop I equals 2, third loop I equals 3. Now just a quick note, actually, you could get rid of that and it will do exactly the same thing. If you don't tell it what to increment by, it assumes you want to count up by 1 each time. I'm going to put it back in because, it makes it a little bit clearer what it's doing. But just remember that that last comma 1 is optional. So now we need to get a reference to the track. Now this raises a complication that we addressed in a previous video. And the complication is that when we have the way Reaper works when it indexes anything, the first one is not number 1, it's actually number 0. Remember, Reaper indexes things starting at index 0. So if we're going to use I to index and get a reference to the track, we actually need our loop to be starting at number 0, not number 1. And if we're moving this from 1 back to 0, we also need to move number of tracks from whatever that number is back to number of tracks minus 1. So this is the right quantity. And now we're starting at index 0, which is what we want. I don't love how that has to be that way in Reaper, but that is the way that it has to be. Cool. So we want to get a reference to the track. Always forget what these are. Get track. Yep. So that gets a reference to a track. So we'll do local track equals. We already have a reference to active project. And each time we go through the loop, the index is going to be I. So that's how we're going to reference the tracks. All right, so find out how many colors are in our colors table. Okay, cool. So local num of colors equals hash colors table. Very good. Now we want to pick a random number between 1 and however many colors we have. So that's math.random 1, num of colors. Fantastic. Use that index to pick a color. So we've already written that here. Random color. So that's a new variable. Random color equals colors table. And specifically, not the whole table, just one of the elements inside of it, and whatever the index, whatever this index is, that's what we're going to pick. However, we want to make sure that it's not the same as the previously chosen index. That's what we want to figure out. Cool. So we want to keep track of the previously used index. So that'll be a variable that we define outside of the for loop. Previous color index equals nil. So what I'm doing here is I'm declaring a variable, but I'm not assigning a value to it. That's what the equals nil is. And in terms of functionality, that's actually exactly the same as just doing this. if you just write local and then variable name, that's creating the existence of a variable, but it's not populating it with any data just yet. So whichever you like to choose, you can either do equals nil, or you could just leave it like that. I might just leave it like this. And the reason why I'm declaring it outside of the for loop is we want it to exist across different loop iterations, right? So conversely, this reference to a track, that doesn't exist across different iterations. When I equals 0, this track reference will be a specific track. It goes through the loop, it does all that stuff, it gets to the end of the loop here, and then it goes up here, and now we're in a different iteration. And until we get back to here, this doesn't exist anymore, because this goes out of all of these local variables. They cease to exist once it gets to the end and back for a new round, a new iteration. They get created and destroyed each time it goes through. However, if you declare it outside of the scope of the for loop, this will exist across iterations. That's why I'm doing it up there. So we declare it up here, it has no value, and then after the first iteration, we keep track of what it is. So keep track of so the previously used color index will be whatever the random index was in this iteration. So when we declare this, it starts off as nil. After the first iteration, it now has a value. And then after the second iteration, it'll have a different value. So we're continually updating that variable with whatever the previous one was. All right, so that takes us to here. If the random index is the same. All right, so if random index is the same as the previously used color index, then choose a different color. Let's keep these comments where they lie, because they might be useful. So if random index is greater than 1, then random index equals random index minus 1. I'm not sure if you've seen this sort of thing before. What we're doing here is we're going to assign a new value to this, and the value is going to be itself minus 1. That might seem a little bit awkward, but I suppose that's how coding works. We say that we're going to assign a value to this, and the value is going to be this. Now, this is a value that already exists, okay? So at this point, it'll be whatever it is, 3, let's say. It's going to evaluate this, so 3 minus 1 is 2, and then it's going to assign that value to here. So now it's 2, and now we move on. Hopefully that makes sense. Move one index up the table. So that's what we've done, right? And when I say move one index up the table, we're going from here to here, so that's minus 1, okay? However, if the index is 1, else if random index equals 1, then random index is the same as the number of elements in the color table. So if we're here, we're going to move to here, whatever the last one is. Cool. So that will make sure that we don't have adjacent colors. And just to clarify, if this happens to be different from this, we don't do any of that. We don't do any moving or shuffling or anything. It just continues on because it's already in a correct state. And then after we've done all our selection process, then we keep track of it for the next iteration. Cool, so we have a good index, let's say. Now we can actually color the thing. So Reaper is American, so they spell color wrong. And I'm Australian, so I spell color correctly. But unfortunately, we can't change the spelling of the preset functions, so we have to compromise our values. So set color on the track that we're looking at in this iteration, and the index color. Right. So, as I'm sure you're aware, we don't actually have any colors here yet. These are all just comments. I was considering breaking the video up, but let's not do that. Let's just push on. It'll be a big video, but it'll be worth it. Okay, so you'll see here that you pass in a single integer, which is strange because that's not usually how colors work. Usually colors are split into three numbers, like I mentioned before, red, green, blue, and there's different color systems that exist, but that's probably the most common. However, this color track requires one integer, which is very weird. So how that works is there is a function somewhere here. Color from native. Yeah, color to native. So let's look at this. So color to native, you pass in the three integers, like I said, you normally do, and it returns like the Reaper formatted number for the color, which is something that we don't really want to know about. And the reason why they give you this color to native is because like you're not expected to sort of learn how they number these things. It's like a even though I just said we don't want to know about it, what it is like a 6-digit hex number, I think. But yeah. So what we're going to do is this table is going to be a set of functions where we pass in the red, green, blue, and this will return a number, like the Reaper formatted number or native number, whatever you want to call it. So when we query like the first element, it's going to be whatever this value was, right? So yeah, to make a nice bright red, we can do full value red, 0 value green, 0 value blue. And we'll keep that comment there. We'll keep all of the comments because it's easier to read that stuff than the number values. So for a nice bright green, that'll be 0 parts red, full parts green, and 0 parts blue. And then blue will be 0 red, 0 green, full blue. Yeah, let's do that for now. Now, one thing about tables is the different elements need to be separated by a comma, like that. The last element doesn't necessarily need a comma, but I always put it there anyway, even though it's not necessary. I just put a comma after every element. Cool, so at the moment we've got 3 elements, and I think that's enough for the script to work. So let's hold our breath. Nope. What do we do wrong? Expected near color. Set the color track. All right, so we actually haven't formatted this correctly. But we have done everything else. Random index, random index. So random color there. I see another mistake in this code. Might even be a good idea to pause the video, identify the mistake that I made, correct it, and then unpause the video. Or if you can't be bothered with that, just keep watching, I guess. But yeah, we'll come back to that mistake. But for now, we're getting colors, which is good. Now you will see that there are adjacent colors. That is the mistake that I was referring to. Cool, so what did I do wrong? Well, what I did was we get our random index and we assign the color, and then we go to all this effort of redoing the index to avoid adjacent colors, but then we don't assign the color again. We don't actually get the color again. So yeah, simple solution to that is this just needs to happen after all of this. So, you know, we pick a color and then we re-pick a color if we need to, and then we get the color. So now let's have a look at what happens. Nice. Very nice. Cool. All right, so let's just keep assigning new colors, and then we'll end the video there, and then we'll talk about like different things you can do with the color scripts. So what I like to do to get more complex colors is open up any drawing tool that your computer has. On Windows, Paint 3D is a nice one. And what you can do is, you know, you can get a color and you can see it, and you can see the breakdown of red, green, blue. So what I'm going to do is I'm going to go through these four, and I'm going to get these values from those. So there we go. I'm just going to move it to the other screen, so you won't see it, but I'm just going to use that to copy these colors. So 41, 120, 56. Remember the comma. So that's the dark green. We also want the orange. That looks like a lovely orange. Whatever. 200, 117, 40. We want a pink for our vocals. Looks nice. 218, 129, 211. And you don't want the dark colors to be too dark, actually, because sometimes you can't see the writing. Maybe something like that. 153, 126, 100. All right, there we go. So remember, you need to put the commas in, and I forgot to do that. And I'll just show you what it looks like when you leave them off. Yeah, right. So it tried to make sense of what's going on, and it actually can't. But at least it told us that the problem was around here. But yeah, the problem is that there are missing commas. So there we go. Yeah, I don't love that brown. That brown needs to change. Yeah, let's do that. That's a good thing about using the Paint program. You can just quickly iterate colors, try it, and then redo it. That's the brown there. That's good. I don't mind that. Cool. All right, so that's the random assignment of colors. In the next video, we're going to look at assigning colors based on what the track is called, which is a permutation of the script that I use much more commonly. So I'll see you in the next one.